Today's lesson is a chapter 10.1 about the Pythagorean theorem. This is the last chapter of your year, so congratulations on that. We all know about triangles, but again, we're going to work specifically with what we call right triangles. Right triangles pretty much are triangles that have a right angle. Essential question is, what is a Pythagorean theorem? Well, there was a guy named Pythagoras, or he also had a group called the Pythagoreans who kind of met and did math ideas. You can always research that. But he or they recognized a pattern in all right triangles, and they noticed that the longest side had a direct mathematical relationship with the two shortest sides. And what they noticed, and you want to go ahead and label this on your page here, your right angle, of course, is shaped like a L, so go ahead and mark that. And what I usually do is I view this L as an arrow, and this arrow is pointing at this side, which is what we call C, or the hypotenuse. Again, that is the weird word, the one word you have to kind of make sure you know. But again, the key thing here is that you must understand that the right angle points at C. What a lot of students do wrong is they see a right triangle, they just say this is C or that's C, and even though these other two sides don't mean much, I mean they're important but they don't mean as much, you have to definitely make sure you pick the right value for C, which is what most of your work is going to be about today. The other sides are A and B. Now again, these two are what we call legs. And so what you need to understand is it doesn't matter if you call this A or this A, because both of these legs are really insufficient when it comes to the formula of the Pythagorean theorem, whereas the most important letter is C. So again, make sure whenever you go to do your work today that you recognize that this right angle is pointing at C. The toughest part outside of that is pretty much the algebra. Like I said, once you get used to recognizing what A, B, and C are, or actually once you recognize what C is, because once you know C, again, everything else doesn't matter. The rest of it is just the algebra. There are three situations you're going to face. And it could be that you don't have A, but you have B and C, which should be easy enough. All you have to do first is make sure you square everything. So you would put your 7 squared, which is 49 if you needed to, equals 13 squared, which is 169. My advice to you is that you always square your numbers first. Don't do anything with these squares here. The second thing we want to do is use our algebra to get rid of the 49. So a squared is equal to 120, I believe. And the last thing we learned was that to get rid of a square, you square root both sides. And yes, you typically use a plus minus, but keep in mind that when you do a plus minus, or that when you do a minus, it means that there's a negative side, and there's no such thing as a negative length. And so what we're going to have going to the nearest tenth would be, actually the 5 is going to bump the 9 up to a 10, which means that's a 0, that moves up to a 1. So it would be, if you're rounding to the nearest tenth, 11.0. Now our computer doesn't do that, but if you're rounding in science and chemistry and biology, things like that, if they want the nearest tenth, they want to know that 0.0 is there. But other than that, that is pretty much what you do. Again, yes, it is a plus or minus 11.0, but negative 11 as a side doesn't make sense, so we don't pay attention to the minus part on that. B, same thing. First thing you want to do is simplify everything you can. So 16 plus B squared equals 100. You then get rid of your 16 by subtracting it, which gives me 84. You then get rid of the square by square rooting. 9.2 would be what you have there. Again, yes, it is a plus or minus 9.2. But the key idea here is that we don't use the negative, so it doesn't really matter in this situation. And then C, again, simplify. So 64 plus 25 equals C squared. This case, because these two numbers on the same side, you're pretty much going to put them together, 64 and 25, which is 89. And then again, to get rid of the squared, square root both sides, which would be about 9.4. So again, those are the three situations you're going to face, but pay attention to the fact that when you have A and when you have B, the situation's the same. You simplify first, you then subtract the number from both sides, you then square root both sides. Whereas with C, you simplify, you add, and you go from there. It really doesn't matter whenever you set up your picture where you put your A or your B, because it's the same question no matter what. Again, the key thing is make sure you understand what C is, because if you don't, that's going to be an issue. Now let's get formally introduced, which I think I've already done. The legs are the short sides of the right triangle, A and B. The hypotenuse is what we call the longest side of the right triangle. Again, it's always opposite of that arrow or that pointer, C. And let's just get to examples so we can get you some work. And again, remember, the best way to learn math is through trial and error. So let's get some of these mistakes out of the way and get you some practice. Two legs of a right triangle measure 17 and 8. Sketch the triangle. Find the length of the third side. Round to the nearest tenth if necessary. It does not matter how you sketch your triangle, as long as you have a definite right angle in it. Even if it doesn't look like a right angle, as long as you put that mark there, you're good to go. Now, you again have to remember that it said the two legs are 17 and 8. And you have to know your definition. This points at the hypotenuse, which means that this should be nothing. So it means a 17 could go here, a 8 could go there. And as they say, it does not have to be drawn to scale. You just have to make sure you understand that one of these is 17, one of these is 8, and that this side is the one we don't know. So this is the side we don't know. Again, because this is my hypotenuse, that means this is my A and B, and it doesn't matter how I use it. But I didn't put the Pythagorean theorem. Sorry. The Pythagorean theorem itself, way back to your triangle here. I meant to do that. Go back to here. Your Pythagorean theorem is a squared plus b squared equals c squared. Sorry about that. That's, I guess, what we came for. Got a little bit ahead of myself. But again, the Pythagorean theorem is a squared plus b squared equals c squared. So the Pythagoreans realize that if you square this number and you square that number, it's always equal to the square of that number. Alright, sorry to have to backtrack. So again, what we have here is a squared plus b squared equals c squared, which means that we'll just put a as 8, because remember, a and b don't really matter in terms of order, plus 17 squared equals c squared, which we don't know, which would be our x squared. You could use a c if you want. And then again, you simplify those two, so you get 64 plus 289 equals x squared. 64 plus 289 gives me 353. And then again, based off of one of those three situations we just saw, you follow the steps that we did, getting about 18.8 equal to your missing value. And that's all it takes. Alright. Another question you might see might say the measure of a leg and hypotenuse are 10 and 27 respectively. Again, sketch the triangle, find the length of the third side. If you've never seen this word respectively, I did that because I need you to understand that what this word means. This means that the order of what they stated is the same order as a number. So since leg was first, hypotenuse was second, 10 is first, which means it's the leg, 27 is second, which means it's the hypotenuse. Respectively, again, this means whatever order the things were stated is what order the numbers are in. Okay? So either way, doesn't matter how you sketch the triangle. We can even sketch it this way. Bottom line is that you have to mark your right angle and recognize that the leg is 10 and the hypotenuse is 27. Well, remember, the hypotenuse is across from this, so that means that this has to be 27. And it does not matter, again, where you put this 10. You could put it over here, you could put it down there. The bottom line is that is my x, or whatever letter you, if you want to use A or B. But the bottom line, again, with the Pythagorean theorem is that it's a squared plus b squared equals c squared. I'll just go ahead and put this in for a, because again, it doesn't really matter in terms of options, because these two work out the same way. But 10 squared plus x squared equals 27 squared. That turns into 100 plus x squared equals whatever 27 squared is, which is 729. You then subtract your 100 from both sides, again following one of the three things that we face in our algebra. And the last thing we do is square root both sides to get the answer of 25.1. You should always notice that this has to be the longest side. In triangles, the longest side is always across from the longest angle. If you do some work and this answer is bigger than that, you messed up. Or if you do some work and this answer is smaller than one of those other two, then you did something wrong. Again, your hypotenuse should always be the longest side in that triangle. One more type of problem you're going to see in terms of what we need to cover is something like this, where a jogger runs 1.5 kilometers south and turns west. The jogger then finishes 1.7 kilometers from the starting point. How far west did they go? This is where you have to kind of understand north, south, east, west. If you don't, let me put that here for you. I think that's east, yep, because that's New York. But either way, north, south, east, west kind of goes like this, and as long as you have a general understanding, you should be okay. Even if you don't, if you get wrong on east, west, as long as you know east, west is left and right, north and south is up and down, you should be okay. But either way, what I would usually do is just start with a dot. This is where the jogger starts at 1.5 kilometers south. So what you do is you put a line going south and label that 1.5 kilometers. They then turn west. And again, it doesn't matter if you really go west as long as you don't go south or north, because you notice I labeled my picture wrong. So again, it doesn't really matter. So what I'm going to do here is make sure we understand that the relationship between south and west or east is 9 degrees. But it said that they finished 1.7. Notice they didn't tell me how far the jogger went west, but they said that they finished 1.7 kilometers from the starting point, and that's what that means. Again, they went 1.5 kilometers south. They went west some distance, but where they stopped, they were 1.7 kilometers from the starting point. And so again, that's where we now put x here, and we use our a squared plus b squared equals c squared. Again, last time we used this as a. Let's just go ahead and use that as a just to show you. Again, it does not matter. So x squared plus 1.5 squared equals 1.7 squared. We then simplify everything. X squared plus 2.25 equals 2.89. If you want to know that trick, 17 squared is 289, but since you squared, it should be 2 digits. 15 squared is 225, but since that's a decimal with 1, it should end up with 2. Anyway, you then subtract your 2.25 from both sides, bringing down x squared equals 64.64. Yep. And the last thing you do is square root both sides. And again, the number I know that makes 64 is 8, which would only make sense that the jogger ran 0.8 kilometers in that other direction. And again, the nice thing about it is you could actually check it. 0.8 squared plus 1.5 squared equals 2.89. Well, if I square root that number, you end up with your 1.7. Again, that's what the Pythagoreans realized was that relationship. There are more types of your problems on your homework, but again, they're already diagrammed for you. In other words, the problem you're going to see are going to look like this. Just make sure you identify the hypotenuse first. That way you can't misplace the key variable. Sorry about this light situation here. We just got new lights in the house, and there's certain things I have to get used to. But anyway, there are more types of problems. Again, they are already done for you. Just make sure you ask whatever you get stuck on so you understand what's going on. And again, make sure you're ready for this last chapter, because I think we'll probably be talking about, we might have already talked about your grades to start. But other than that, good luck, and let's knock out the rest of this year.